Part 2 of this lecture deals with the process of elaboration, which is a technique designed to explore bivariate relationships by examining the influence of additional control variables or third variables. There's 3 different possible types of relationships, including spurious, intervening, and conditional relationships. A spurious relationship is one where the independent and dependent variables aren't related to each other causally, but both are caused by some kind of prior or control variable. That is, the control variable explains the way the relationship between the variables. So, for example, here's a diagram depicting the relationship between an independent and a dependent variable. In a spurious relationship, it's not that the independent variable directly causes the dependent variable, but in fact that the two are caused by some kind of control variable that causes both. As a concrete example, consider the relationship between shoe size and intelligence among a sample of elementary school kids. So if you went to an elementary school and you collected information on kids' shoe size and their IQ, you would probably find that as their shoe size increases, so does their intelligence. However, it's not the case that shoe size directly causes intelligence. Rather, there's something else that's affecting both, and that thing is the process of aging. And so we know that as people get older, their shoe size gets bigger, and so does their intelligence. So in fact, age is the thing that's causing both. And so there's a spurious effect of shoe size and intelligence that's due entirely to age. In an intervening relationship, we have some kind of control variable that intervenes directly between the relationship between the independent and dependent variable. In other words, the independent variable doesn't have a direct effect on the dependent variable, but there's a third variable that goes in between the two. And so, rather than having an independent variable cause a dependent variable directly, what we have is the independent variable causing some control variable, which then causes a dependent variable. As a concrete example, consider the following. We all think that as people get older, they get more income. And so we might think that there's some kind of a direct effect between age and income. But actually, it's not the mere fact of getting older that makes people get more income. It could be something like having more job experience that means people get more income. And so as people get older and they get more job experience and they get promotions and they get raises, that's the thing that causes them to get higher income. So in fact, there's an intervening relationship between age and income that involves job experience. Onto a conditional relationship. This is one where the control variable's effect conditions the effect of the independent variable on the dependent variable. That is, the relationship changes on the value depending on the values of the control variable. So it's not that an independent variable directly causes a dependent variable, but it's that a third variable is conditioning that relationship and influencing it so that it takes on a particular value for one value of the independent variable, but a different value for a different value of the independent variable. Consider the relationship between gender and income. We might think that men and women have different earnings on average. We might think that men as a group tend to earn more than women. But maybe it's not solely due to gender. Maybe there's another influence, something like education, that also influences the earnings of men and women. So maybe men get paid more, not only because they're men, but also because they're maybe more educated than women. So we can test something like this looking at a conditional relationship. So we can use the process of elaboration to determine whether the effect of a control variable is affecting the bivariate relationship that we're looking at. And using the process of elaboration basically involves looking at the original relationship between the independent and the dependent variables, but separately for the categories of the control variable. We accomplish this by using something called a partial table. So a partial table just shows the original relationship between independent and dependent variables for a subset of cases according to their value on the control variable. So if we use the variable x to refer to an independent variable, y to refer to a dependent variable, and z to refer to a control variable, and let's say that value z takes on values of either 1 or 2, we can make a partial table by taking the original relationship of x and y and separating it into separate tables. One for the relationship between x and y when z is equal to 1, and the other for x and y when z is equal to 2. And then we just interpret the relationships we find in the partial tables, and that tells us whether we have a intervening, spurious, or conditional relationship. So, if we have a spurious or intervening relationship, we have evidence for that if the partial relationships are weaker than the original. Unfortunately, we can't determine on a statistical basis whether we have a spurious or an intervening relationship. We have to do that on the basis of theory. If it's a conditional relationship, that means that the partial relationship for one of the categories of the control variable is going to be stronger than the original, and the other is going to be a weaker relationship. So the one doing the conditioning is the one that has a stronger relationship, and the other has a weaker relationship. As an example, let's consider the relationship between church attendance and abortion attitude. So imagine that we thought that abortion attitude was associated with church attendance. Let's say that we thought that people who attended church more frequently were more likely to be opposed to abortion than those who were not. And so let's code attendance as either frequent attendance or infrequent attendance. Here's a bivariate table showing the relationship between church attendance as an independent variable and abortion attitude as a dependent variable. Is there some kind of relationship here? Well, if we look at the percent differences for one of the categories, and it doesn't really matter which one we choose, we get the same relationship either way since this is a 2x2 table. Here we see that there is a difference in the percentages of people who frequently and infrequently attend church in terms of their support for abortion. So we can see that those who frequently attend, only about 30% of them are in favor of abortion, whereas those who infrequently attend, it's a much higher percentage, over 57%. And so we can see that the difference between these is about 27%. So if we take 57.27, subtract 29.6, we get a value of 27.67. Now, what if we thought that there was no direct relationship between church attendance and abortion? What if we thought that it was actually something that was conditioned by some other factor, specifically religious preference? So suppose we thought that there was a difference between the effect of attendance on abortion attitude for those who have some kind of religious affiliation versus those who don't. And so here we can kind of write that as a diagram. So it's not that attendance directly affects abortion alone, but attendance in conjunction with a particular religious belief or preference is what especially makes that relationship strong for one group but weak for another. So to examine this conditional relationship, we need to construct a set of partial tables. And these partial tables will be constructed in such a way as to look at the relationship between church attendance and abortion, separately for those with religious preference and those without religious preference. And so we're going to look at something like this: the original relationship between attendance and abortion in two partial tables. The first partial table will look at this relationship for only those people who have some kind of religious preference, and the second will look at it for those people who have no religious preference. And if there's a conditional relationship, we should find that one of the partial associations is stronger than the original, and the other is weaker. Okay, so first, let's look at the partial table for only those people who have no religious denomination. So it turns out that there's 228 of those people. And notice that the relationship here is the following. Those who infrequently attend church, about 70% of them say that they support abortion. Whereas those who don't attend church frequently, only 36% of them support abortion. This is among people who have no religious affiliation whatsoever. And so here there's about a 34% difference, and that's larger than the original, which you recall was about 27%. Now let's look at those people who have a religious preference, those people who have some kind of religious denomination. And there's 1,018 of them. And so we can see here that the percent difference is a little bit weaker than the original. So for those people who have a religious preference, it looks like 51% of them who infrequently attend church support abortion, whereas 29% of them who frequently attend church support abortion. And so that difference is about 22% when we do the arithmetic. And that's actually smaller than the original. And so, in summary, what we found is that in one of the partial tables, we have a stronger association than the original. And in the other, there's a weaker association. And taken together, that is evidence for a conditional relationship. And so we can say that church attendance is related to abortion attitude, but especially for those who have no religious denomination. They're particularly likely to favor abortion if they infrequently attend church, whereas those who that have some religious denomination, the relationship is actually somewhat weaker.